Similar triangles. Similar triangles, or I guess it'd be under triangles similar. I am going to give you the story problem right before we do it, and then we'll talk about this. So here is the problem. This is what this is talking about. By the way, this is real world applications. In other words, you can't ask me when will we ever use it, because you could actually use this. Applications. Listen to this very carefully. And here's where you have to organize your thoughts. And this is another case for writing stuff down. Okay. Bob wants to know the height of a flagpole. Bob wants to know the height of a flagpole. Now, what might be Bob's problem with finding the height of a flagpole, Brookline?
Probably measure that high.
Why would it be tough to measure that? Why is it tough to measure a flagpole? Jules?
It's really tall.
It's really tall. It's hard to get a ladder up that tall, and if you did get a ladder up that tall, what would you rest it on without endangering your life? Yeah. So you want to come up with some way to be able to figure out the height of a flagpole without, without getting on a ladder. Well, let's just well, obviously you could guess at it, but that isn't always a good idea. Any thoughts on how you could find the height of a flagpole? Riley?
You can cut it down.
How about a realistic one where you'd actually, you could cut it down, but then it pretty much loses its usefulness there. Keith?
Use triangles.
Ooh, Keith, knowing that what this lesson's about, says yes, we could use some triangles. How could we use it? We got a suggestion here? Is it worth mentioning, or is it just you trying to be funny? Yeah, if you have to think about it, we're not pursuing that. So anyways, here's what's going to happen here. So Bob wants to know the height of the flagpole. Keith knows that it's, obviously it deals with triangles because that's what our section is here. Here's what it says. He stands a meter stick in a vertical position and finds the length of its shadow. Bob stands a meter stick vertically, that's what it's called, and finds out that its shadow is 120 centimeters long, and finds its shadow 120 centimeters long. Now I'm going to sketch that little picture before we do the rest of the problem. In other words, he takes a meter stick and sets it on the ground and stands it upright. Here's my meter stick. How tall would my meter stick be? 1 meter. And realizes that here's Mr. Sun up in the sky shooting down its rays, and finds that the shadow the sun makes with that meter stick, here's its shadow, is 120 centimeters long. And the beauty about that is this is probably, since he sticks it in the ground straight, this is a right angle. And it is, if you connect this point with that point, you can make yourself a nice right triangle. How about that? Isn't that special? Then he looks and Bob measures the shadow of the flagpole. So here's your flagpole, which is much taller. A little blurry on that. And he knows that the shadow, here's the deal, he can't measure the shadow because he doesn't need to get on the ladder. And measures it that is 30 meters long. 30 meters long. And if you connect this and the sun's rays and all that sort of stuff, what you have here is you get, two similar triangles. How do I know they're similar? Well, okay, because they have a right angle here, and the sun's rays are going to shoot off them at the same angle, even though it actually wouldn't be exactly the same, but it's going to be awful close because the sun is so far away. So you know that these two triangles are similar. These angles are the same. And what do we know about similar triangles? All their sides are proportional. So here is what you need. This is the important part about this. Okay, you need to draw your ratio box, because you're going to make some equal ratios here. Okay, and I would label them this way just to make sure you get this kind of right. You've got the small triangle here. You've got the large triangle here. And what two things are we comparing? We're comparing their height to their shadows. And you just fill in the boxes there. What is the height of the small triangle? What is the height of the small triangle? Now here's what you want to do. You want these two measurements to be the same thing. If it's 100 meters, how tall is that in centimeters? Or 1 meter is how many centimeters? Sorry, did I say that wrong? Right. You know that the height of the small triangle is 100 centimeters. The shadow of the small triangle is 120 centimeters. You know the height of the flagpole is not known. And you know that the shadow of the flagpole is 30 meters. Now it is okay that these measurements are different. This doesn't have to be in centimeters. Okay, these two have to be in the same, these two are going to end up being in the same, but they don't all have to be the same, because this is just the ratio and the proportion there. So as you do this, what's it going to look like? It's two equal fractions, you just don't know that one there, so it ends up being 100 over 120 equals what number over 30? And your answer will be in meters. It'll be the same meters as that there. Quick way to do that? Is there a simpler way to do it than just cross multiplying? 120 twice, going 3 times? No, yes. What can you do, Mitch?
Do you see how 8 times 30 can go into 120?
Well, you could. You could say, how do I go from 120 to 30? What would you do to 120 to get 30? Well, actually, don't times 4, because 120 times 4 would be 480. See, the problem with doing it your way is this. You have to think this way. Yeah, to go from 30 to 120, it's multiplying by 4, but I don't know what do I do to what number to get 100 multiplying it by 4. It's really, you have to think backwards, and it would be division. 120 divided by 4 is 30, so 100 divided by 4 is 25. Now what you could have done, you could reduce these two. What goes into 100, 120? They both end with zeros, right? So you could do what? Take those zeros off. Now it's 10 over 12. 10 12s can be reduced to what? 5 6. And does 6 go into 30? Yeah. Times 5. 5 times 5 is still. Your flagpole is 25 meters tall from here to there, which would be a long ladder. 25 meters is, actually that's pretty tall, isn't it? How tall is 25 meters? 75 feet. How tall is 75 feet? That's a whopper of a pole. Isn't it?
It's like almost like Easter egg.
75, 25 meters. That's as taller than a tree, isn't it?
Yeah, just a little bit.
Here's another one. So if you can draw the triangles, you know, then you should have a pretty simple time here. Hold on, and then here's where it gets a little more complicated. Check out this one. I'm going to write this down. It's going to take you a little while here. Holding a ruler upright at arm's distance, a lot of words here, people, by the way. At arm's distance, Ronnie aligned the bottom of the ruler, bottom of the ruler with a mark on a utility pole. Wow. With a mark on a utility pole. Mark on a utility pole. That was about 5 feet above the ground. Now I should stop there, just so you can see the picture. And again, a lot of this doesn't make sense until you actually try to sketch it out. Even then, sometimes it doesn't make sense. So here's your little Ronnie. What is Ronnie doing? He has the bottom of a ruler at arm's length. He sticks his arm out. Okay. He aligns the bottom. Here's the ruler. He's holding the ruler out in his hand. He aligns the bottom of that ruler. There's this big old pole over here. He aligns the bottom of that ruler with a point that's 5 feet above the ground on this utility pole. Okay, so that's what we know so far. That's what this says right there. Then it goes on to say, he saw that the top of the pole, he saw the top of the pole aligned, read that, with the 6-inch mark on the ruler. With the 6-inch mark on the ruler, which means this. Take a look, see. So here's his ruler. Here's a 6-inch mark. It's about halfway up. That's 6 inches. And the top of the pole aligned with that. 6-inch pole. I guess we're assuming his head is kind of in that way. Then he took 40 strides to reach the pole. Then he took 40 strides to reach the pole, which means from here he walked all the way to the pole. How far was it? 40. Wrong person. Strides. If each stride was about a yard, each stride about a yard, about 1 yard. Here comes the question. Then the top of the pole is about how many feet? How tall is the pole? Intriguing, isn't it? Real life world applications there. Oh, I forgot to tell. And the book also said this. The arm's distance, they said it was about 24 inches. Which is true. Your arm's about 2 feet long from here to there. So you know this is 24 inches, correct? So there you go. How tall is the pole? First thing I would strongly recommend doing, boys and girls and children of all ages, is I would read, well, not, you already drew this, but I would sketch out the two triangles that you're comparing from. What two triangles are they? You've got this triangle here, right, which is 24 inches by how tall? 6 inches. That's your little triangle here. And then you've got this big triangle here, which is, what do we know about it? We don't know how tall it is, but we do know this distance from here to here. They said each stride was about how far? A yard, which is 3 feet. So how many feet would this be from here to here? 3 times 40 is 120 feet. So can we find the height of this from here to here? Sure we can. We just use that little thing that I gave you. Remember the little table I said it'd be best to do this? We've got small triangle. We've got big triangle. And what are we comparing? We've got the height. And we're comparing it to the length. You could call it a shadow if you want, but it doesn't matter. So on the small, how tall is it on the small? 6 inches. How long? 24 inches. On the big triangle, we know the bottom, and we don't know the height. Don't know the height. So here is your ratio that you need to solve. 6 over 24 equals what number over 120? Anybody know 24 times what is 120? Or should we reduce it? Lady, should we reduce it? 6 and 24 reduced down to what? Did you say 1/4?
Yep.
That's what I thought. 4 times what is 120? Brianna? 30. So 1 times 30 is, that's a tough one. Anybody do 1 times 30 in your head? Riley, can you do 1 times 30 in your head?
No.
Keith? What do we get?
30.
Yes, look at that. So we know this is 30 right here. Is that my answer? How tall the pole is? No, why is that not my answer? Colquitt, why is that not my answer? This is 30 from here to here. Why is 30 not how tall the pole is?
Because you have to have the whole pole, not just a triangle.
And what is the whole pole?
3 times 5.
Not 30 times 5.
3 plus 5.
30 plus 5, yeah. Remember he said he lined it up 5 feet above, so that part of the triangle is 5 feet above the ground. So 30 plus the 5 is 35 feet tall. Which would only be about half of that flagpole. I'm still mesmerized by the height of that flagpole. That's incredible. So what's going to be the, oh Mitch, what?
How do you know like the other half of the pole is 30 feet?
Because I sketched my triangle up here and that's how tall that side had to be, the missing part of it. I have the small triangle, which is this one. The big triangle is this one. And I use those ratios. Small over small equals big over big. That's where the 30 came from, yeah, the 30 to the 5. I mean, this is actually something you could really do out in the real world. If it was sunny out today, we would actually go out and do this. We could figure out, ooh, we need a shadow though. Ever seen people do this?
It's 6 o'clock.
What's that? You could do that easily by, you know, if you stuck your thumb up. This is about 24 inches there. Your thumb is probably, what's that, probably 3 inches? You just line that up with some building, marched off the bottom. You could figure out how tall stuff is. Whoa. Without even knowing, like really tall things. The Empire State Building.
I'm confused how you got the 2 inches on the small.
Oh, the what?
2
The,
inches on the small.
the 24? This is
Oh, it's
24. What did you know? It told, the story problem actually said it. Remember I said, when I read this, I said, holding a ruler upright at arm's distance, and then I said the book said arm's distance is about 24 inches. So you will have to be given 3 of the 4 measurements you need, otherwise you will never be able to do the problem. The book, in the story problem, in those 200 words you read, they have to give you enough information to draw 2 triangles and have 3 out of the 4 sides that you need the ratios to compare. So, yeah. As a matter of fact, look at, open your books to page 443. 443.